Do you remember a couple of lessons back when I was talking about container independence? I was saying that in the Unity container, which was originally made by Microsoft, you can resolve a component even if that component hasn't been registered. And I was saying how that could be a reason for migrating. Well, in actual fact, AutoFac also supports such functionality, and it supports it through something called a registration source. So let me give you a very simple example. Let's suppose that I have some sort of interface. Let's call it I can speak. I have a void speak method inside that interface. I then have a person, and that person can speak. So we implement the I can speak interface like so. I can speak. There we go. Let's implement the missing members here. I'll just console.writeLine hello. Now let's suppose that I decide to actually resolve this in a container. I say b.resolve person and then please speak. Now obviously this will crash because we haven't registered the container inside of the container builder. We haven't made that registration, so we're going to get an exception. Now you could just go ahead and register the type, but you can also specify a registration source, and this registration source will take care of any unregistered components, and it will try to construct them anyway. So this source has a really long name. It's called any concrete type not already registered source. And the way you would add it is something like the following. You would say builder dot and then register source. So a registration source is essentially just a definition of where you might look for additional components to register. So here you would make any concrete not already registered source. So this is rather long-winded, but the end result is that if I now execute the program will actually run correctly and it will give me hello, even though I haven't registered the person to be an active participant of this entire setup. So I haven't registered the type explicitly. Now what we're going to take a look at is how you can register your own sources, and the scenario that we're going to use for this particular setup is a bit more complicated than the scenario which we have just looked at, where we used a ready-made source, because we'll have to delve into some of the functionality which is actually provided by AutoFac in terms of extending AutoFac in actual fact, because that's what you're doing. So let me give you a small setup of what we can do. So let's suppose we have an abstract class called base handler, and this abstract class defines a way of generating event handlers. So essentially we'll have a public virtual string handle function or method which will take some message, and we'll just say that we have handled this message. So return handled and then the message. All right, so this is our base handler. We might have a couple of implementations of base handler. So we might have handler A, which is a base handler, and we can override the handle. So I'll just type handle here. Actually, it's not helping me find the override, so let's do it the old-fashioned way. Override and then handle like so. So here I will return handled by A colon and then the message, and I will just duplicate all of this and have the same as handler B. I'm sorry we're not being more specific here, but because we have to generate so much scaffolding just to illustrate this idea, I'm going to go quick here. So here are my two handlers. Now let us suppose that I have some sort of iHandler factory. So I want to have a factory implementation which actually makes these handlers. So I make an interface called iHandler factory, which is going to return a type T in the method called getHandler, and this is a generic method which takes a type argument T, where T is obviously a base handler. Now we can have a concrete implementation, so we can create a derived type called handler factory, and in this handler factory we'll implement the missing members, and for our very simple demonstration we can just construct a default instance of T. So we return activator dot create instance of T like so. That's all that we're going to do. Now we're going to have a couple of consumers, and these consumers are going to be referencing the handlers, and when necessary they're going to do a certain amount of work which will then be processed by the handler. So for example, we'll have consumer A as the class which is going to reference handler A. So I'll say handler A. I'll generate the constructor for it, and in addition I'll have some method called doWork, and inside this method we're going to just console.writeLine whatever it is that the handler A does when it handles something. So I say handler A handle, and then I'll say consumer A, just so that we know where this comes from. I'll replicate all of this, so I'll just duplicate the code, and here I will get rid of the constructor. We'll regenerate it in a second, but I will change this to handler B, like so. So we're going to have handler B and handler B here. I'll have C_F once again, and of course this is consumer B. Now the whole point of this setup is to give you a demonstration of something which is very difficult to incorporate into the container itself, and maybe we don't want to incorporate this into the container itself. So what we're going to do instead, to automatically register the handlers themselves and to make sure that they actually work, is we're going to make a registration source. So we're going to build a class which is a handler registration source, and it's going to implement an AutoFac interface called iRegistration source. Now this interface isn't particularly straightforward, so I will not delve into the specifics of its members. Suffice it to say that we need to return false for indicating whether this is an adapter for individual components. So I will put a false in here, and then we have to implement this registrations for method. Now what do we have to put in this method? Well, we have to essentially be able to detect the kind of registration that the container is looking for, and this is something that is going to be invoked during the build stage. So when the container is built up, it's going to use all the registration sources which have been provided in order to look for additional components. So here inside registrations for, first of all, we need to make sure that we are working with some sort of base handler type. So here we try to get the service that we're building up with a type. So we say var SWT equals service as iService with type, and if we have been successful in terms of getting the service, then everything is okay. But we need to check that SWT is not null, and if it is null, or the service type that it exposes is null, so if or SWT.service type is equal to null, or this is just the wrong type which isn't assignable to a base handler. So if not SWT.service type is assignable to base handler, then we quite simply jump out of this method. And because this method returns an IEnumerable, we can do a yield break here. As soon as I learn how to spell yield break, there we go. Okay, so assuming that everything is successful and we are in fact working with something derived from base handler, what we can do is we can yield a new component registration. So we can add an additional component registration. Yield new component, well, it's actually yield return new component registration. There we go. So component registration has a couple of arguments which we need to specify, and we're going to do this right now. So the first is a GUID to identify this registration. We'll just do GUID.newGUID here, nothing fancy. And the second one is the important one. So here we need some sort of activator which will actually define what's going to happen in terms of well, invoking the actual component. So here what I'm going to do first of all is I'm going to make the assumption that the factory which is going to manufacture these components, so the handler factory which we have right here, has already been registered in the container. And then what I can do is I can make a new delegate activator. Okay, and this delegate activator is going to specify the type that's being built up. So we will say SWT.service type. And in addition, it takes a function which defines what happens with the parameters and everything, and the component context and how these can be used to invoke something. And we do need to invoke something. So here I'll just use code completion and generate it like this. I'll call the context C, and I will call parameters P for short. Just P. Okay. So what we're going to do here is, first of all, we'll resolve the iHandler factory. So we'll say var provider equals c.resolve iHandler factory. There we go. So that's step one. After having resolved the factory, we actually need the get handler method, and we need to basically specify the appropriate get handler method to be invoked. So let's do that. So the next thing would be to get the method, and this is done using reflection because it's generic. So we say provider dot get type, and let me just show you where this appears. So this appears here. So we need to invoke this particular method somehow, and we're doing it using reflection. So we're saying provider.getType.get method called getHandler, and then we just say make generic method. There we go. And here we have to specify the parameter type, and of course the parameter type is that service type. So here we specify SWT dot service type, like so. Okay, and then the final thing that we do is we invoke the method. So we return method dot invoke, and we specify the provider, and the second argument, which is the parameters, is going to be null. So what's going on here? Well, essentially we're specifying this delegate that will be invoked to manufacture new instances of these handlers by using the factory that we've provided. So we have this handler factory which is capable of making handlers, and we get the method to making an appropriate handler where the type is the service type, the type that's actually being resolved, so to speak, when you build up the container, and we invoke this on the factory to actually make something. Okay, so there are a couple of parameters that we have to close out. So after we have the delegate activator here, what is the next part? Well, we just need a few more things. First of all, we need the scope lifetime. Now these are kind of internal objects. I'll just use the current scope lifetime here, and then we'll use the instance sharing of none. We'll use instance ownership owned by lifetime scope. Now we need to provide the set of services, so here I'll just make an array with the single service that we already have. And then here you need to provide an iDictionary, so I'll just make a new empty dictionary like so. And that's pretty much it. Now we need to close the round bracket, and we are done in terms of making this registration source. And now, of course, it's time for us to actually use it and to try and figure out what exactly did we just do. So here is my container builder. First of all, I will register the type of handler factory. That's the factory that can actually build these handlers. I'll register it as an iHandler factory, like so. Then I will register source. I will register the new source, the handler registration source. That's the registration source that we've just built. And then I will register the consumers. So I'll register type consumer A and consumer B as well. You'll notice that I am not registering the handlers themselves. So the container is actually going to go off looking for handler A and handler B, and it's not going to find them, unfortunately, because we haven't registered them. And we also made a couple of mistakes here. Let me just fix this real quick, because I think that we forgot a curly brace or a semicolon somewhere. Okay, so this entire thing is actually spurious. Right, so now that we've registered both of the consumers, what we can do is build up the container and then try to resolve each of the consumers. So I'll c.resolve consumer A, and then do work as soon as I once again learn to spell correctly, do work like so, and I'll do the same for consumer B as well. Okay, so here's the interesting part. We are not registering the handlers themselves. However, we registered both the factory, and the registration source kind of knows that the factory is able to acquire these particular components. So what we can do now, in addition to obviously executing this, is we can also debug into the function that we defined here, the registration for, and in this function we can look at the types which are being requested. So first of all, I want to just execute this and show you that it does in fact work. Okay, so handled by A, consumer A, handled by B, also consumer A, probably because of a cut and paste error that I made. Yep, that should have been A, B here, but it does work. The whole setup that we just made, it does in fact work. But what we can do, we can put a breakpoint. So here is my breakpoint. I'm now going to debug this. And so as we jump into the registrations, we can look at the service variable and its type to see what exactly AutoFac is looking for. So at the moment, AutoFac is looking for any components which are iStartable. I'm going to press F5. It's looking for components which are auto activate. I'm going to press F5 again. It's looking for consumer A. And inside consumer A, we're using that unregistered handler A. So when I press F5, you can see that the service is in fact handler A. And this is where, instead of doing a yield break, like in most of the cases, we're actually going to yield return a new component registration. And it's precisely this new component registration that actually makes the handlers available, and subsequently the consumers actually make use of them.